In this video, I'll talk about some of the frequently asked questions on factor analysis. One of the most often asked question on factor analysis is how is factor analysis used in data analysis? Well, factor analysis as such is not a statistical technique. So how is it used? How it helps in building statistical models. Well, if not directly, indirectly it helps a lot. So one of the most important use of factor analysis is doing variable reduction. So you can, if you have a large data set, large number of variables are there, then you can reduce to a lesser number of variables by using factor analysis. The second use is when you have highly correlated data, like the attributes or the variables you have are highly correlated. So when you have highly correlated variables, you cannot use or you cannot build a good model. So to get rid of the highly correlated variable and to get down to a smaller number of uncorrelated variables, you can use factor analysis. And the last use, which is more technical in nature and less understood, is finding out the latent factors. Factor analysis helps you in finding out what are the unobserved or what are the hidden factors behind certain events or certain occurrences. Okay, for example, say for example there is customer satisfaction. Okay, satisfaction. Now customer satisfaction is something that cannot be seen, but it is hidden in some factors, right? So factor analysis will be able to find out the hidden factors by grouping number of variables. So what it does is it groups in certain way, it groups variables or attributes and gives the hidden factor. So somebody who is familiar with factor analysis will understand the last point, but nevertheless the first 2 points can be the first two uses of factor analysis is very important and can be performed by anyone who is only who has only basic knowledge of factor analysis. The next question often asked is, what are the differences between the exploratory factor analysis and the confirmatory factor analysis? Somebody familiar with factor analysis must know that there are two types of factor analysis broadly. One is exploratory factor analysis and the other one is the confirmatory factor analysis. The difference is uh, in the application of these two techniques. Well, the exploratory factor analysis is used to explore the underlying factors, whereas the confirmatory factor analysis is used um, to confirm the underlying factors. And we have talked about the factors in the previous questions. Let me give an example. It will be clearer. Okay, so I've got we're doing customer satisfaction. So this we have a survey data. We have customer satisfaction. Okay, so it's a survey data. So from one say from 1 to 5, some people have got ratings on customer satisfaction. Now customer satisfaction depends on the suppose the color of the product, then um, the number of days the customer has used this product, number of days, and then the uh, the service help provided by the company, and the replacement cost. Okay, and it could be we can have more number of variables as well. Okay, now I've got four variables. Customer satisfaction depends on the product features like color and number of times it has gone for repairing, and then services, and how much cost the customer had to incur for replacement, and so on. Now, through exploratory factor analysis, one can um, explore the relation between these variables, okay, and come up with some latent variables, okay. Now you can see the first two variables are the feature of the product, okay. So we can say that this two variables represent one factor known as satisfaction with product, satisfaction with product, and the next two variables are somewhat related to satisfaction with service, okay. So the overall customer satisfaction depend on two main factors: satisfaction with product and satisfaction with service, okay. Satisfaction with service and satisfaction with products. Now these are the two underlying factors. So mathematically we can represent that customer satisfaction is equal to some form of uh, uh, product satisfaction plus service uh, satisfaction with product plus satisfaction with service, okay. So that's the equation. Now whether this equation is correct, so this is what you have, this is just an hypothesis, okay. This is just an hypothesis. To confirm this hypothesis, to confirm that this representation is correct, you need to do the confirmatory factor analysis. So always you start with the exploratory factor analysis, come up with this representation of the model, and then confirm the representation that you have got from the exploratory factor analysis by using the confirmatory factor analysis. So that's the basic difference. Next question that is often asked is what are the differences between the factor analysis and the principal component analysis. This is a controversial one because PCA and factor analysis have come from different academic subjects, so there is a conflict, but the basic differences are, well, there is a similarity also. The uses of PCA and exploratory factor analysis in particular, they're pretty much the same. PCA is used for variable reduction. Exploratory factor analysis is also used for variable reduction. So the uses are pretty much the same, but the difference is mostly on computation. The way the principal component or the principal components are computed, and the factors are computed in in factor analysis. So that's the basic difference between the factor analysis and the principal component analysis. So one of the mathematical difference I'll provide here, and it's very important and often asked in technical round interviews. So in the factor analysis, every variable, say variable 1, is a linear combination of beta 1 plus factor 1 plus beta 2 factor 2. Whereas if it's a principal component, it is a linear combination of variable 1, variable 2, and so on. It could be more number of variables as well. So here is the difference. In factor analysis, each variable is a linear combination of hidden factors like factor 1 and factor 2, which are unknown, and you determine that. Whereas principal component, in the case of principal component itself is a combination of linear combination of variables. So it is the reverse, or it is the opposite of the way the factors are calculated in factor analysis. So that's the main difference between PCA computation and the factor analysis, computation of factors. What are rotations in the context of factor analysis? This is also an important question. Many times you will want the factors to be completely uncorrelated. Okay, that means say there are two factors in a data analysis, factor 1 and factor 2, the correlation between f1 and f2 should be 0. And when does that happen? The two variables or two series are uh, you know have 0 correlation when they are perpendicular to each other. Okay, so this is factor 1 and this is factor 2, right? So this is perpendicular. That means they are orthogonal in nature. Orthogonal in nature. In that case, the correlation between factor 1 and factor 2 is 0. Many times this is a requirement, right? Well, these factors will be used as independent variables in the models, and you know that if the independent variables are totally uncorrelated, it's good for the model, right? Hence, in that case, you'll be using the orthogonal rotation of the factors. So that's one of the rotation. Many a times you want some kind of a correlation, that you expect that there is some kind of correlation between the factors. In that case, you will not be using orthogonal rotation. There are other kind of rotations available in which you can actually keep some sort of correlation between the factors. The last question I'll be discussing is what are the uses of factor analysis? Like, where can you use? Like, factor analysis is not a variable is not just a variable reduction technique. It is used as some sort of a modeling technique in a number of scenarios. And one of the most important scenario where factor analysis is used in the business, I'm not talking about the academics. It's in business, is in marketing. So in the case of survey data, if you have survey data, you are doing survey analytics, factor analysis is heavily used. So it's used for like, for example, it's used for knowing factors affecting consumer satisfaction. In academics and in other spheres, it's highly used in psychometry, where the researcher try to find out the factors responsible for performance of students. Performance of students in class. What are the performance factors, like economic factors, then education of parents, and social factors, and so on. So these are cases. So whenever you have you expect some hidden factors to be responsible for occurrence of something, then factor analysis, both the exploratory and confirmatory factor analysis, will be handy techniques to be used.